Tartar is not calcium deposits or food residue. It is a living bacterial city, with a shared defense wall that makes it up to 1,000 times harder to kill than the same bacteria floating freely in your mouth. Conventional toothpaste was designed to fight individual bacteria. Tartar is not individual bacteria. It is a biofilm, a structured colony with its own protective architecture, and nothing in standard oral care is aimed at dismantling that structure. Today we go inside the biofilm, why it keeps rebuilding after every cleaning, and the 4 ingredients that attack it at the structural level rather than the surface. We will get to the one ingredient most people think is too harsh that turns out to be gentler on enamel than every commercial toothpaste on the market. Think about the last time your dentist scraped tartar off your teeth. It came back, didn't it? That did not fail because you brush badly. It failed because the problem starts deeper than any toothbrush reaches. When bacteria transition from free-floating cells into a biofilm, they secrete a protective matrix of polysaccharides, proteins, and DNA that encases the entire colony. This matrix actively blocks antimicrobial agents from penetrating, reducing the effective concentration of conventional antiseptics by up to 1,000-fold, according to a 2019 review in Nature Reviews Microbiology. The same concentration of chlorhexidine that kills a free-floating bacterium in seconds cannot reach the same bacterium embedded in a mature biofilm. This is why brushing removes surface bacteria but leaves the biofilm architecture intact. The colony rebuilds from the protected core. Within days, mineral salts from saliva deposit into the matrix, the calcification process that produces tartar. Scraping removes the calcified result. It does not dismantle the architecture producing it. Target the matrix. Everything else is maintenance. Within 2 hours of brushing, a protein film coats every tooth surface and bacteria begin attaching. By 48 hours, the colony has established quorum sensing, communication channels through which bacteria coordinate behavior collectively, including producing more matrix to reinforce defenses. As the colony grows, it ferments available carbohydrates, sugars, refined starches, producing lactic acid as a byproduct. A 2021 study in the Journal of Dental Research found that biofilm-produced lactic acid reduced local pH at the tooth surface to below 5.5, the threshold at which enamel demineralization begins, within 3 minutes of carbohydrate exposure. At that pH, calcium phosphate leaches out of enamel. The bacteria do not eat your teeth. They create an acid environment that dissolves them. Starve the biofilm of carbohydrates, and the acid production stops. The relative dentin abrasivity scale measures how much a substance wears down the dentin layer beneath enamel during brushing. Baking soda scores 7. The average commercial toothpaste scores between 70 and 150. Some whitening toothpastes reach 250. The most common concern about baking soda, that it damages enamel, is precisely backwards. A 2017 review in the Journal of the American Dental Association, examining 15 clinical studies, found baking soda significantly more effective at removing plaque than non-baking soda toothpastes, while producing no measurable enamel wear across any study in the dataset. As sodium bicarbonate, it also neutralizes the lactic acid the biofilm produces, raising oral pH back above the 5.5 demineralization threshold. Your body produces sodium bicarbonate in saliva for exactly this purpose. The gentlest abrasive available also neutralizes the acid destroying your enamel. Halfway through, and we have not yet touched why hydrogen peroxide and raw honey are 2 of the most clinically validated biofilm disruptors available, or what vitamin K2 research shows about keeping calcium out of the soft tissue that becomes tartar. If this is reframing how you think about oral health, subscribe. Every week we go deeper into the mechanisms that standard dental advice rarely has time to explain. Stay with us. Your immune cells produce hydrogen peroxide as a primary weapon against bacterial biofilms. It penetrates the extracellular matrix and generates reactive oxygen species that disrupt bacterial membranes from within. A 2020 study in Frontiers in Microbiology found that low-concentration hydrogen peroxide, at 1.5% to 3%, significantly reduced oral biofilm mass and disrupted matrix integrity without damaging gingival tissue. Raw honey operates through a parallel mechanism. It contains enzymatically produced hydrogen peroxide plus methylglyoxal, concentrated in Manuka honey, which disrupts biofilm through a separate pathway. A 2016 study in the Archives of Oral Biology found that Manuka honey inhibited Streptococcus mutans biofilm formation at concentrations achievable through direct oral application. Two mechanisms, both already present in your body's own defense system. Use them together and you attack the matrix from two directions simultaneously. The biofilm produces lactic acid. Lactic acid drops oral pH below 5.5. Below 5.5, enamel dissolves. This is a three-step sequence, and the most direct intervention targets step 2. Raise the pH before demineralization begins. Baking soda does this chemically through acid-base neutralization. But the carbohydrate supply feeding step 1 matters equally. A 2019 systematic review in Carey's research, analyzing dietary patterns across 55,000 participants, found that reducing fermentable carbohydrate intake, particularly between meals, was the single strongest dietary predictor of reduced karyogenic biofilm activity, outperforming fluoride use in populations with high baseline carbohydrate consumption. Cut carbohydrates, neutralize the acid. The biofilm loses its weapon. Tartar is calcified biofilm, mineral salts depositing into the bacterial matrix until it hardens. The calcium doing the depositing follows a distribution pattern influenced by vitamin K2. K2, specifically menaquinone 7, found in raw fermented dairy and organ meats, activates a protein called osteocalcin that directs calcium into bone rather than soft tissue. A 2020 review in the International Journal of Molecular Sciences found that adequate K2 status was independently associated with reduced ectopic calcification across multiple tissue types. The research on tartar specifically is preliminary, but the mechanism is consistent. K2 redirects calcium away from soft tissue deposits. Get K2 from raw cheese, egg yolks, and grass-fed butter daily. The mineral that builds tartar follows instructions. K2 changes the instructions. Tartar is not a hygiene failure. It is a biofilm management problem. And the solution is not scrubbing harder with a more abrasive paste. It is dismantling the protective matrix before it calcifies, neutralizing the acid environment that makes calcification possible, and cutting the carbohydrate supply that keeps the colony fed. 4 ingredients: baking soda, hydrogen peroxide, raw honey, and clove or peppermint oil, built on the same chemistry your body already uses. Twice a day, soft bristle brush, consistent.